Hello everyone. Today we shall look at M42, the Orion Nebula. The Orion Nebula, also known as Messier 42, or NGC 1976, is a diffuse nebula situated in the Milky Way, being south of Orion's belt in the constellation of Orion. It is one of the brightest nebulae and is visible to the naked eye in the night sky with an apparent magnitude of 4.0. It is 1,344 light-years away and is the closest region of massive star formation to Earth. The M42 nebula is estimated to be 24 light-years across. It has a mass of about 2,000 times that of the Sun. The Orion Nebula is one of the most scrutinized and photographed objects in the night sky and is among the most intensely studied celestial features. The nebula has revealed much about the process of how stars and planetary systems are formed from collapsing clouds of gas and dust. Astronomers have directly observed protoplanetary disks and brown dwarfs within the nebula, intense and turbulent motions of the gas, and the photoionizing effects of massive nearby stars in the nebula. In short, this object has taught us how our own solar system came about 4.5 billion years ago. It contains a very young open cluster, known as the trapezium cluster due to the asterism of its primary four stars within a diameter of 1.5 light-years. Two of these can be resolved into their component binary systems on nights with good seeing, giving a total of 6 stars. The stars of the trapezium cluster, along with many other stars, are still in their early years. The trapezium cluster is a component of the much larger Orion Nebula cluster, an association of about 2,800 stars within a diameter of 20 light-years. The Orion Nebula is in turn surrounded by the much larger Orion Molecular Cloud Complex, which is hundreds of light-years across, spanning the whole Orion constellation. 2 million years ago, the Orion Nebula cluster may have been the home of the runaway stars Ae Aurigae, 53 Arietis, and Mu Columbi, which are currently moving away from the nebula at speeds greater than 100 km per second. The red color of the nebula is due to ionized hydrogen, usually called hydrogen alpha. Basically, this means that a hydrogen atom has been absorbing energy, pushing its only electron up from the first level to the third level. As the electron slowed down and goes back down to its natural state, it releases the extra energy in the form of a photon. The wavelength of the photon is 656.3 nanometers. In other words, it gives us red visible light. The blue-violet coloration is the reflected radiation from the massive O-class stars at the core of the nebula. The green hue was a puzzle for astronomers in the early part of the 20th century because none of the known spectral lines at that time could explain it. With better understanding of atomic physics, it was later determined that the green spectrum was caused by a low-probability electron transition in doubly ionized oxygen. The history of the nebula. Neither Ptolemy's Almagest, written in the 2nd century, nor El-Sufi's Book of Fixed Stars, from the 10th century, noted this nebula, even though they both listed other nebula elsewhere in the night sky. Galileo also failed to mention it, even though he also made telescopic observations surrounding it in 1610 and 1617. This has led to some speculation that one of the stars flared up, thus increasing the brightness of the nebula. The first discovery of the diffuse nebulous nature of the Orion Nebula is generally credited to French astronomer Nicolas-Claude Fabry de Peiresc, on November 26, 1610, when he made a record of observing it with a refracting telescope. Charles Messier observed the nebula on March 4, 1769, and he also noted 3 of the stars in trapezium. Messier published the first edition of his catalogue of deep sky objects in 1774, completed in 1771. As the Orion Nebula was the 42nd object in his list, it became identified as M42. In 1902, Vogel and Eberhard discovered differing velocities within the nebula, and by 1914 astronomers at Marseilles had used the interferometer to detect rotation and irregular motions. Campbell and Moore confirmed these results using the spectrograph, demonstrating turbulence within the nebula. In 1993, the Hubble Space Telescope first observed the Orion Nebula. Since then, the nebula has been a frequent target for HST studies. The images have been used to build a detailed model of the nebula in 3 dimensions. Protoplanetary disks have been observed around most of the newly formed stars in the nebula, and the destructive effects of high levels of ultraviolet energy from the most massive stars have been studied. In 2005, the Advanced Camera for Surveys instrument of the Hubble Space Telescope finished capturing the most detailed image of the nebula yet taken. The image was taken through 104 orbits of the telescope, capturing over 3,000 stars, including infant brown dwarfs and possible brown dwarf binary stars. In October 2023, astronomers, based on observations of the Orion Nebula with the James Webb Space Telescope, reported the discovery of pairs of rogue planets, similar in mass to the planet Jupiter. Rogue planets are planets that have left the solar system where they were formed. I hope to make a video on this subject at a later date. The nebula is part of a much larger nebula that is known as the Orion Molecular Cloud Complex. The Orion Molecular Cloud Complex extends throughout the constellation of Orion and includes Barnard's Loop, the Horsehead Nebula, M43, M78, and the Flame Nebula. Stars are forming throughout the entire cloud complex, but most of the young stars are concentrated in dense clusters like the one illuminating the Orion Nebula. In 1979, observations with the Lallemand electronic camera, at the Pic du Midi Observatory, showed 6 unresolved high ionization sources near the trapezium cluster. These sources were interpreted as partly ionized globules. Later observations with the Very Large Array showed solar system-sized condensations associated with these sources. Here the idea appeared that these objects might be low-mass stars surrounded by an evaporating protostellar accretion disk. In other words, solar systems in formation. In 1993, observations with the Hubble Space Telescope yielded the major confirmation of protoplanetary disks within the Orion Nebula, which have been dubbed proplyds. Hubble has revealed more than 150 of these within the nebula, and they are considered to be systems in the earliest stages of solar system formation. The sheer numbers of them have been used as evidence that the formation of planetary systems is fairly common in the universe. Stars form when clumps of hydrogen and other gases a region contract under their own gravity. As the gas collapses, the central clump grows stronger and the gas heats to extreme temperatures by converting gravitational potential energy to thermal energy. If the temperature gets high enough, nuclear fusion will ignite and form a protostar. The protostar is born when it begins to emit enough radiative energy to balance out its gravity and halt gravitational collapse. Typically, a cloud of material remains a substantial distance from the star before the fusion reaction ignites. This remnant cloud is the protostar's protoplanetary disk, where planets may form. Recent infrared observations show that dust grains in these protoplanetary disks are growing, beginning on the path towards forming planets. Once the protostar enters into its main sequence phase, it is classified as a star. Even though most planetary disks can form planets, observations show that intense stellar radiation should have destroyed any proplyds that formed near the trapezium group, if the group is as old as the low-mass stars in the cluster. But since proplyds are found very close to the trapezium group, it can be argued that those stars are much younger than the rest of the cluster members. When I see all the information yielded by the observation of this small patch of sky, I am reminded of Carl Sagan's words.
The cosmos is all that is, or ever was, or ever will be. Our contemplations of the cosmos stir us. There's a tingling in the spine, a catch in the voice, a faint sensation as if a distant memory of falling from a great height. We know we are approaching the grandest of mysteries. The size and age of the cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planetary home, the Earth. For the first time, we have the power to decide the fate of our planet and ourselves. This is a time of great danger, but our species is young and curious and brave. It shows much promise. In the last few millennia, we have made the most astonishing and unexpected discoveries about the cosmos and our place within it. I believe our future depends powerfully on how well we understand this cosmos in which we float like a mote of dust in the morning sky.